This is concept 58, adding and subtracting rational expressions. For adding and subtracting like basic rational expressions, these are very straightforward, and they work just like any other fractions you would be adding, right? The denominator stays the same, and your numerator are the terms that you're going to add or subtract. Okay. The only thing that we saw in concept 57 that's also part of this one is that you have to simplify. Okay, and that's step 3 here. So just pause the video, read the 3 steps, okay, and yeah, and then that's it. So first one, I have 13a over 4a squared plus 5a over 4a squared. So just like I said, your fractions, when you add them, your denominators are going to stay the same in terms of 4a squared, right? And then 13a plus 5a, you get 18a, and you're done. Okay. Actually, we're not done. Forgot step 3, simplify. Okay, I can simplify top and bottom. Cancel out here, down cancels, I get 1. And then 18 over 4, I can divide the top and bottom by 2, so I get 2 and 9. So this is 9 over 2a. That's it. That's my answer. For number 2, same thing. In terms of 16, 9x, so it's 9x minus 7x, so I get 2x. 12 minus 2, so I get plus 10. And then I can simplify. I can factor out a 2, right? I'll show every step for this one. So I get 2 times x plus 5 over 16, and then 2 over 16. 2 over 16 does simplify. I get 1 over 8, so I get x plus 5 over 8. Okay, so how do these get more challenging? Starting with number 3. Okay, notice that now I have these quadratics, difference of squares, these type of expressions. So that means you're gonna have to, in addition of adding expressions together, you're also going to be able to simplify. So, or simplify further as opposed to like number 1. So in the top, or let's see, these are definitely y squared minus 9 at the bottom, right? And I get y squared plus no y squared terms here, so no like terms to add with it, so it just stays as y squared. 8y plus 2y, those are like terms, so I get 10y. And then I have nothing here but just a plus 21 there, so there's no like term to it, so I have that right there. Next thing I want to do is simplify. So I got a factor. The top is 7 and 3 there. 7 times 3 is 21. 7 plus 3 is 10. Over, and then that's a difference of squares, right? Square factor of y squared is y. Plus and minus, square factor of 9, 3, and 3. Now I can cancel out these guys here, and I get y plus 7 over y minus 3. That's it. Number 4, I have like base, so 12a minus 3 in the denominator, and I get 1 minus 16a squared. Nothing I can combine there, but I can simplify here. I can notice that the top is a difference of squares. Square factor of 1 is just 1 plus 1 minus. Square factor of 16a squared is 4a. Then the bottom, I can factor out 3. So 3 times 4a minus 1. Now 4a minus 1 in the denominator, I have 1 minus 4a. This is that property from the previous concept, right? So we're gonna we can say these two are equivalent to -1, and then from here I get -1 minus 4a over 3, and that's my final answer. For number 5, I get, so I have n squared minus no like term, so it's just n squared 3n minus n, so 2n, negative 7 minus 1, so negative 8, over n squared plus n minus 6. This can factor out. I get what is it, n plus 4, n minus 2, and then the bottom is n plus 3, n minus 2. These guys cancel, and I get n plus 4 over n plus 3. For number 6, so I have that same denominator. For the top, I have 13k squared plus k squared, so those are like terms. I get 14k squared, and then negative 9k plus 2k, I get negative 7k. So then I can factor out a 7k, and I get 2k minus 1 over, and this is going to be one of those quadratics, right, that from the previous concept, 6 times 1, you get 6. Are there factors of 6 that add up to negative 5? Yes, negative 6 and positive 1. So then you'd be able to factor from there what would be the like term. I can, just take it slow if you have to, okay? That way, pause the video and see if you could factor it out. But when you do that, you're going to get, let's see, you're going to get 3k, 2k, because you get 6k squared, 3k plus or minus 1, because you get negative 3k, so minus 1 here as well, because negative 2k, you get negative 5k, negative 1 times negative 1 is positive 1. Okay, from here I can simplify. There, those cancel, and I get left with 7k over 3k minus 1. That's it. So this is the like-based examples. Hopefully these weren't too bad. Where do they get a little more challenging is when you have unlike-based examples. This is two ratios that just do not have the same denominator, right? There's a pretty straightforward trick to these. Let me grab a different color here. Okay, so what you're doing is multiplying, in most cases, both ratios so that they have the same denominator. 2x, they work just like before when you would add or subtract fractions that did not have the same denominator. You would multiply to see to get that least common denominator, right? Same thing here. In those cases, you're just going to multiply both by that same to get whatever. Okay, sorry about that, guys. You're going to multiply top and bottom here by this leading coefficient, and you're going to multiply top and bottom here by this leading coefficient. So the first one is by 3 and 3, so that's going to give me the least common denominator, and then the second one multiply by 2 and 2. That's equal to, you're going to get 45 over 6x minus 32 over 6x. Now I have that that same denominator, so that's equal to 45 minus 32. You're going to get 13, and then over 6x, and there's nothing you can simplify further. You're done. For the next one, okay, you have a squared and you have a there, so there's really, what you're going to have to do is multiply this fraction here by a squared, okay, because by a, so you could get a squared, because that would be the least common factor there for the least common denominator, between a squared to a. Then for the first fraction here, you have 8, right? If you're gonna have 8a squared here, you're gonna multiply this one by 8. So this one goes by 8 and 8. You're gonna get, oops, so that's equal to 32a over 8a squared minus 7a over 8a squared. Now we have that same denominator, 32a minus 7a. You're going to get 25a over 8a squared, and we could simplify this a with this a, right? They cancel out. You have 2 in the bottom, so then your final answer would be 25 over 8a. Okay. Next page. Now we have a binomial in the bottom, but it works the same way. Okay, just have to think, okay, what can I multiply whether it's just one or both to get the same thing? This one here, okay, 5k minus 10. You can factor out a 5, right? So it's just really k minus 2. Here's k minus 2. So then that means you can multiply this one by 5 to get that same denominator. So you're going to get k squared plus 16 over 5k minus 10 minus 20 over 5k minus 10. Now I have the same denominator. So combine the numerators. There's so 16 minus 20, you're gonna get k squared minus 4 over 5k minus 10. Now we simplify. That's equal to, the top is the difference of squares. So you got k minus 1, k, whoops, not minus 1, minus 2, k minus 2, k plus 2, over, and then I can factor out a 5 from the denominator. I get 5k minus 2. These guys are going to cancel, so I get k plus 2 over 5. For number 10, this one is a lot trickier. So because you have a trinomial and a binomial. Okay, now the trick here is, let's factor this guy out so we can see what we have to multiply this guy by to get this. Okay, so what I'm doing here is, first, right below it, we're gonna rewrite that denominator. Okay, and if I factor this out, I get y plus 8, y plus 3. So this is equal to y plus 8 times y plus 3. I have y plus 8 right here. So then that means I can multiply this top and bottom by y plus 3. And then that's going to give me the same denominator. Okay, so I get 7y plus 21, right? That's 7 times y plus 3 plus, oh no, sorry, over, and we can leave it factored because we're going to be simplifying anyway. Okay, let's skip a step. I know I already have the same denominator, so I'm going to leave it like this. This becomes 7y plus 21 right here, right? And then when I added both these fractions, because now they're the same denominator, I can extend and I have that 35 here. Okay, now I can factor out the top. Okay, and it seems like, did I mess this up? No, I didn't. Okay, I can combine these two, 7y plus 21 plus 35. You're gonna get 7y plus 56 over y plus 3, y plus 8, running out of space here. Now I can factor out a 7 on top. I get 7y plus 8 over y plus 3, y plus 8, and then these two guys are going to cancel, and I get left with 7 over y plus 3. Okay, yeah, that's it to it. Number 11. So same thing, you wanna rewrite the denominator here so you can see what you need to multiply the other ratio by. X squared plus 5x plus 6, that's x plus 2, x plus 3, right? And then you already have x plus 2 here, so you gotta multiply top and bottom by x plus 3. We're getting, and I'm going to skip a step, so x squared minus 5, that's from here. I already know that they're both going to have the same denominator, so I can just go ahead and add, plus 1 all over x plus 2, x plus 3. Combine the terms on top, I have x squared minus 4 over x plus 2, x plus 3. And then the top here is a difference of squares. So this is x plus 2, x minus 2 over x plus 2, x plus 3. These cancel, so I get left with, forgot a parentheses there, so I get left with x minus 2 over x plus 3. Number 12, continuing the same thing, except now numerator is also going to be something that's factorable, but works the same way. Okay, want to start with the denominator so we can combine these first. I'm getting, let's see, I'm getting this here is the difference of squares, so m plus 2, m minus 2. I already have an n minus 2 here, so I'm going to multiply by m plus 2 top and bottom. Okay, I'm adding, so let's just put all that together. M squared plus 5m plus 6 plus 2m plus 4, right? Because 2 times m, 2 times 2, I get 2m plus 4, all over m plus 2, m minus 2. Now let's combine like terms on top. M squared, 5m plus 2m, I get 7m. 6 plus 4, I get 10 over m plus 2, m minus 2. Now I can factor out the top. I get m plus 5, m plus 2 over m plus 2, m minus 2. And I can factor out, sorry, I can cancel out those two, and I get left with m plus 5 over m minus 2. Okay, we're almost there. 4 more. Okay, for 13, this is one, so I think we haven't seen one like this yet. So this is one that you can't simplify or rewrite an expression on either ratio. And yeah, so where would you go from here? This is similar to those, actually similar to, I think it was on the other page, where you're just going to have to multiply by what's in the denominator to each fraction, to each other one. So this is w plus 1, so you have no choice but to multiply top and bottom of the other one by w plus 1. Okay, and you're going to do the same thing to the left one by w minus 7. And observe that you have w minus 7 times w plus 1, and the other one's w minus 7 times w plus 1. So now you made these denominators the same, therefore you can add them now. So the top here would be 5w minus 35, and then plus 8w plus 8, right? That comes from here. So then that's over w plus 1, w minus 7. Combine like terms, I'm getting 13w minus 27 in the numerator over w minus 7, w plus 1 in the denominator. And there's nothing, there's nothing I can simplify from here, so that's it. We're done. Number 14, similar case to the previous one. There's nothing you can really do to factor or simplify first to try to get both terms. So you're going to do the same thing. You're going to have to multiply top and bottom here by b plus 3, because that's what I have here in this denominator. And then similarly, because this is going to give me b squared plus 3b, you're going to have to multiply top and bottom here by b, what's in the other denominator. That's going to give you the same expression. So b times b, I get b squared minus 4b, so 4b plus 12, but it's a minus, so you get negative or minus 4b minus 12 over, let's keep them separated, b plus 3, since we're going to be simplifying anyway. Okay, the top you can you can factor that. B and b, negative 12 to negative 4, you're going to get negative 6 and positive 2 over b plus 3. Actually, yeah, that's it. There's nothing I can do from here, so I'm done. Okay. Alright, last two. You're gonna want to, oh boy, this is let's see, let's rewrite the one on the right here in the bottom and see what those binomial factors are, and see how we can compare to the left one. So I have p minus 5 minus 3, so p minus 5, p minus 3. Then let's see, if I factor out a 4 here, I can make this into 4 times p minus 5. Okay, I have p minus 5, p minus 5, so I'm going to need a p minus 3 here. Okay, so I'm going to multiply this one here by p minus 3. But this one has a 4. This is the one that this one's lacking, so I'm going to multiply this one top and bottom by 4. Now I have 4 times p minus 5 times p minus 3, 4 times p minus 3, p minus 5, so it's all the same. Okay, now I can combine them. 2 times p minus 3, so I get 2p minus 6 plus p, 4 times p, so 4p, 4 times minus 6 minus 24, all over, and then I get let me see, I got p, let's do 4, let's write the constant first, p minus 5, p minus 3. Let's combine like terms. I get 2p plus 4p, I get 6p, minus 6 minus 24, negative 30, over 4p minus 5, p minus 3, and then I think I can factor out a 6 on top, so I get p minus 5 over 4p minus 5, p minus 3. I can cancel these out. 6 over 4, this becomes 3 over 2, and I think that's gonna be it. Yeah, so I get 3 over 2 p minus 3. That's my final answer. Okay, last one. So I think it's gonna be the same case. I have to rewrite both sides. So I get factor out of r here, and I get r plus 4, and then in the left side I can factor out a 2, so I get r plus 4, 2r plus, yeah, so we're almost the same, r plus 4, but this one has a 2, this one has a r, so this one's lacking a 2, this one's lacking a r. So multiply top and bottom here by r, and you're going to multiply top and bottom here by 2. R times r, you're going to get r squared minus 8 times 2, 16, all over 2r, r plus 4. Sorry, I think you guys can hear the garbage truck outside. I apologize if it's loud. Okay, the top is a difference of squares, so I have r plus 4, r minus 4, and then all over 2r, r plus 4. Then I can cancel out r plus 4, and I'm getting r minus 4 over 2r. And then that's it. I can't simplify further. And that's it. This wraps up concept 58.